Okay, so back to this. Okay, so again, this is lesson 7. We're going to prove angle pair relationships. We're going to see the right angles, the complementary, supplementary, vertical angles. These will be some of the common angle pairs we're going to see. Okay, so again, this is our right angle congruence. And as Jason told us, that the second reason was definition of right angles. And the first one was given. Good. All right, for letter C, how do we know that, or what did we do? Isabella?
Definition of congruent angles?
We didn't change from a congruency mark to an equal sign. We did something else here. What did we do here? David?
Is it the transitive property?
This looks more like, I guess we could say transitive if we flip it around. So you could either have said transitive or substitution. If you flip this around, then the 90s would match up. So we could say substitution. And then now when we went from the equal sign to the congruency symbol, this is where we would say definition of congruence. Yes. So for the last statement, definition of congruence. Now that we've proven this theorem, if you were to be given a statement, we could cut out those two middle things and we could go right from the beginning to the end and just say all right angles are congruent by the right angles congruence theorem. So if they ended up giving you a statement, angle 1 and angle 2 are right angles, if they gave you the given, and they wanted you to prove this, because we've now proven this theorem, we could cut out these two steps, and we could jump right to the end, and instead of that reason, we would say by the right angle congruence theorem. Everybody understand what I just said? So really it would just be the two steps, the given, and then it's already been proven, and you just say by the right angles congruence theorem. Okay, next theorem is going to be the congruent supplements theorem. And here, if two angles are supplements to the same angle or to congruent angles, then they are congruent. So here it's saying if angles 1 and 2 are supplements, so right here and right here, and 2 and 3 are supplements, then angle 1 is congruent to angle 3. So this is your congruent supplements theorem. Everybody good on this side? Okay, let's go to the next one. All right, now we're going to prove that congruent supplement theorem. We're going to be given that 1 and 2 are supplements and 3 and 2 are supplements. Again, we want to prove that 1 and 3 are congruent. Okay, so for statement number 1, what is our reason? Given. Number 1 is given. For statement number 2, what did they do there? Michael?
Definition of supplementary.
Good. Number 2 is definition of supplementary angles. And statement 3, what did they do there? How did they modify step 2 and make it into step 3? Jason?
They substituted the measured angle 3 plus the measured angle 2 for me.
Beautiful. Substitution. And then what did they do from 3 to 4? Yes, Michael.
I actually have a question.
Okay, go ahead.
Transitive wouldn't work for number 3, right?
Transitive. If they flipped it around, let's see. We could have, yeah, you could have matched the 180s. Yes. You're going to end up using substitution more often than transitive. All right, what's the next reason? Yes.
Subtracting angle 2.
Good. They subtracted 2 from both sides. Good. So subtraction, property of equality, you can just put subtract. And now from 4 to 5, what changed? Notice the equal sign went to a congruency symbol, so? Yeah, so definition of congruence.
For the last one, can you just put proof or no, you have to put?
You have to put a reason. So def of congruent. Pretty good on that one? So again, here we have the congruent complements theorem. It's the same as the supplements, except for they're going to add to 90 degrees because they're complementary. So here it says if two angles are complements to the same angle or to congruent angles, then they are congruent. So it's first telling us that angles 1 and angle 2 are complementary, and so are 3 and 2. So then we can prove that angle 1 is congruent to angle 3. And the steps for the proof would be the same. Okay, we're not going to go through the proof. All right, next we're going to talk about the linear pair postulate. And here it says if two angles form a linear pair, then they are supplementary. So this is a postulate. We don't have to prove postulates. We're just going to memorize the postulate. Anybody still need this slide? Okay. It says that if two angles form a linear pair, then there are supplements. And then supplementary. Okay. Next we have a definition. And again, we're not going to prove the definition. We just have to memorize the definition. That two angles such that the sides of one angle are opposite rays to the sides of the other angle. So it's basically telling us how to create these vertical angles. We're not seeing that they're congruent yet. That's going to be in the theorem. So right now we're just being able to identify what a vertical angle looks like. And we're defining it. So 1 and 3 are vertical here. And 2 and 4 are vertical. And we covered this before. You could also think of it as this is the letter V, and then put a line here, VA. You could do it across the top and say here is a V, and then an A down here at the bottom, vertical angles, whatever little trick to help you remember which one is vertical. So vertical, sort of like on the opposite sides of an X. Now, let's go back and see what it's angles. We're going to see the vertical angles theorem. And the vertical angles theorem, we have to prove this, and we'll be proving it on the next slide. The vertical angles theorem states that vertical angles are congruent. So So once you identify them, you will know that angle 1, because it's vertical to angle 3, they are congruent. And angle 2 is vertical to angle 4, so they are also congruent angles. So the theorem tells you that the angles are congruent. The definition describes what a vertical angle is. Okay, so now we're going to prove the vertical angles theorem. Now again, once we do this proof for the theorem, again, we wouldn't have to do this again. So our given information is that 5 and 7 are vertical angles. We need to prove that they are congruent angles, that 5 is congruent to 7. So step number 1, what is it? Given. Step number 2. Yes.
Definition of a linear pair.
Good. Definition of a linear pair. Good. Number 3. Michael?
Definition of supplementary angle.
Let's find one that we just did. Give me a postulate for this one. Yes.
Linear complements theorem.
No?
Linear pair postulate.
Good. The linear pair postulate. And then step 4.
Wait, how would number 3 be definition of a linear pair postulate?
Number 3.
Yeah.
It's just the linear pair postulate equal 180. So it's just stating that they're supplements. Okay. So if 5 and 6 are supplements and 6 and 7 are supplements, then what would be our reason for step 4? Yes.
Substitution.
Let's do at the beginning. What did we learn? Like this, what was it? The first postulate? No, probably the second postulate. The one after the right angle theorem. What was the next one we learned? Let's see if you can find it.
Congruent supplement theorem.
Beautiful. Congruent supplement theorem. That's our reason here. So if they're supplementary angles, then they are congruent. Yes?
Is it gonna be like a different answer you could put, like, could you put definition of vertical angles, like, could you put that instead of that? Like, is there different answers you could have for each of them?
There could be different answers or there could be extra steps, yes.
Like, for number 4, like, let's say I put definition of vertical angles, would I be right? Or would I-
Well, definition doesn't include the congruence. Definition just tells you how they're created. And we were trying to prove the vertical angles theorem, which stated that they were congruent. So we couldn't use the theorem we're trying to prove as our reason. Everybody good on this slide? Last slide. Let's see what it says. Okay, so we have an example here, and we want to classify, or some examples, and we need to classify these as true and false. So the first one says, if the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees, then angles A, B, and C are supplementary. True or false? And if it's false, why do you think it's false? Yes?
Is it false because only 2 angles can add up to be supplementary?
Beautiful. Okay, it is false because we only need a pair of angles, and we've got 3 of them listed. So we can't have 3. So that's why it's false. We only needed a pair. Number 2, vertical angles have the same measure? Paulina? True. Okay, we just proved that theorem. All right, bless you. Number 3, if angle 1 and angle 2 are vertical angles, the measure of angle 1 equals 2x plus 8, and the measure of angle 2 is 3x plus 4, then x equals 14. Is this true or false? How can we figure out if they've solved it correctly? Kelly?
You said that equal to each other.
Good. Let's try that. Let's see what we get. So
Could you just also just plug in 14 in each and see if they're equal?
you could? Yes. Okay, so we're going to set them equal to each other. I'm going to subtract the 2. And I get 8 equals x plus 4. Subtract 4. And I find out x equals 4, not 14. So this one is false. Any questions on these true false?